So is my screen visible? Do you guys see my screen?
Yes, sir.
Okay, great. Okay. Okay. So the topic for today is MSTP, which is also called as multiple spanning tree. Okay. So we discussed with the legacy spanning tree and then we went across RSTP. Okay. Now we are going through the last version or the last flavor of spanning tree. Now, how is multiple spanning tree different than these two? Okay, so we know that legacy STP had some timer issue, which was fixed later on the rapid spanning tree, which is very faster in terms of convergence. If the legacy STP takes 50 seconds, the RSTP takes less than one second to converge. Okay. Now, when we have a better RSTP, when we have a spanning tree which can do the work, why do we need MSTP? Okay. So the thing is, these two spanning tree protocol works on a per VLAN instances. Okay, that means if my number of VLANs are 10, then there will be 10 instances of each one running. Okay, so in the sense, let's say I have a Cisco device. Okay, let's say as of now I only have STP. So in case if I have 10 VLANs configured within this, then it's equivalent as saying 10 instances of STP running. How is that? So let's say I have VLAN 1, VLAN 2, 3, 4, 5, 6, and so on till 10. So STP will be running on every VLAN. Okay, so STP instance for VLAN 4 will be separate, STP instance for 5 is separate. So basically there would be 10 numbers of or 10 instances of STP. So let's say if I have 50 VLANs, now I would be running 50 instances of STP. Okay, now what happens is the process within a switch for STP keeps on increasing. Okay, and that's getting or that is giving us more overhead on the device. So even though timer was fixed in RSTP, even though the timer issue was fixed in RSTP, now we have a faster convergence protocol. The only drawback of this is it's again on a per VLAN basis. If someone has 100 VLANs configured on a device along with RSTP, so there will be 100 instances of RSTP running on, okay, which is causing overhead on the devices. So what we do is we go with the multiple spanning tree. So how this help us is, so let's say I have 100 VLANs on one Cisco device. Now what I can do is I can create two instances. I can create three instances also. I can create four instances also. Okay. I'm just giving an example of only two instances, something like this. So let's name it as instance number 1 and instance number 2. Out of 100 VLANs, I'll configure the first 50 VLANs on this instance, map to this instance, and I'll configure next 51 to 100 VLANs in the instance number 2. Now, the important thing is only one BPDU will be sent, which will carry all the information of instances. Let's say I have multiple switches, like 4 switches. Okay, I am going to make two instances and I'm going to map some VLANs to this instances. It don't have to be 50, it can be 10 also. Let's say I'm mapping 20 VLANs to this instance, another 20 to this. Similar way, I have other switches with two instances. So let's say I have 20 VLANs mapped to this instance, another 20 to this, so on. Okay, so let's say I have two more instance and two more. Now In a MSTP, it's only one BPDU packet that will be taking care of all the instances, all 40 VLAN information, all instances, all the two instances is taken care by only one BPDU messages. Okay, that is a advantage of using MSTP. In case of your RSTP or STP, each instance will take one BPDU. Let's say if I have, so in this case, I had 40 VLANs. So let's say I have 40 VLANs. So that is equivalent to having 40 STP instances or 40 RSTP instances. Now each instances will be taken care forward by each BPDUs. So let's say this BPDU is taking care of the RSTP instance number 1. Similar way, the second BPDU. So basically, there are so many BPDUs across in a network, right? So this is causing network issues also. So we already checked the overhead issues, network issues. Now it's a network issue. That is the advantage of making use of MSTP. MSTP will reduce the BPDU flow. Everything can be carried just in one BPDU. You don't have to carry separately. And second thing is, you just have to create instances and you can map number of VLANs. The third important thing is, when you make use of MSTP versus your legacy STP or RSTP, is when you have when you have STP or RSTP, one of the link would be blocked. Agree? One of the link could be uh, blocked. But in case of MSTP, we can make use of those links, and that concept is called as load balancing. Okay, so how do we make use of this is, let's say I have two instances and the same two instances I also have on the second device. Let's say I have first 20 VLANs mapped to first instance, second 20 VLAN mapped to the second instance. Okay, similar way, the first 20 I'm mapping with this instance and the second 20 I'm mapping over here. Now I can say this is the root bridge or root port for this instance. This switch number 1 is a root bridge for this instance. At the same time, I can say that the second instance number 2, is the root bridge for in a switch number 2. Now what happens is, your VLANs will be always forwarding, okay, because you're dividing and you're configuring the MSTP. Okay, so once I do the lab, you will be in better position. So as of now, the three important advantage are, you're decreasing the BPDU flow with the help of MSTP. One BPDU will take all the information of the instances. Second important thing is, it is going to load balance. Okay, whereas in the case of legacy or STP, your port will be blocked, right? We checked port called uh, alternative block. We also saw something called backup block, right? Whereas in this case, uh, we are making use of load balancing concept. Okay, so we are dividing the VLANs in two instances. One instances will be primary on one box, the second instance will be primary on the second box. Okay, so throughout, the VLANs will be flowing across on all the links. Okay, so VLANs will be flowing across the links. That was the second thing. Third one was the overhead on each one of them. In this case, I said multiple instances of spanning tree would be running, whereas in MSTP, it's about how many instances we create. So one instances will have 10, 20, 30, any number of VLANs configured. Okay, so let's see some more theoretical concepts here, and then we will practice some labs. Okay, so regarding the MSTP features, so as I told you, the first point refers to the load balancing. How is load balancing getting supported in MSTP is, the port which was blocked for some specific VLAN may be forwarded for another VLAN. That means, let's say I have two switches. I'm going to create two instances. First instance is 1, 2, 3, 4 VLAN. Second instance, let's say 10, 11 and 12 VLAN. I have mapped 1, 2, 3 to the first instance and 10, 11, 12 to the second instance. Now same mapping will also happen on the switch number 2. I'm going to map 1, 2, 3 here, and I'm going to map 10, 11, 12 here. Now let's say I have two links. So by default, one link has to be blocked. That is what we learned, right? In this case, what I can do is I can say that this should be primary and this should be secondary. Whereas in the switch number 2, I call this as secondary because I have already made use of primary in this switch. So now I'll make this as secondary and this as primary. So what happens is all the time, whatever, let's say if VLAN 1, for VLAN 1, this was an blocked port. Now that might be enabled, that might be forwarding for 10, 11, 12. So that is what it says. When some ports for specific VLANs are blocked, maybe that is forwarding for other VLANs. So that is a concept of MSTP load balancing. So you are making use of the blocked link also in case of MSTP with the help of instances. Now MSTP have instances, concept of instances. Okay, multiple VLANs will be mapped to instances, and it's only one BPDU message which will contain the information of every instances. Okay, so let's say if I have a switch, I have two instances. One instance mapped with 10 numbers of VLANs. Second instance might be mapped with 5 VLANs of VLANs. Now I don't have to see 15 BPDU message sent. Okay, in my STP and RSTP, it's per VLAN. But in case of MSTP, it's just one BPDU that will be taken out of that switch, which will carry information of everything. So that is lowering the network packet flow. Okay, so it's decreasing the network flow. What about the third one? Standard maximum number of instances can be 64, including default instance 0. Now this is some new things in your MSTP configuration. Okay, so let's say I have a Cisco switch where I'm running MSTP. Now question is, how many instances can I configure? So we know the number of VLANs, right? So number of VLANs are 1 to 1005 and extended ones are from 1 to 4094. So your MSTP is going to support the extended VLAN. Now, can I map all 4094 on one instance? Or can I make use of 2 instance or 3 instance or 4 instance and then map accordingly, like 20 VLANs here, 30 VLANs here, 40 VLANs here, 50? Can I do that? So that is something which this statement says, the number 3. It says that maximum I can configure 65 instances. Okay. Out of 65, 64 is configurable by myself. One instance is getting created by default. Okay, it is getting created by default by the MSTP process. As soon as you enable MSTP, your instance number 0 will be automatically created. Now we will talk about that. What is the purpose of instance number 0? How is it helping us? Okay, so the point here is this instance 0 will as soon as get created when I enable MST. Now I am left with 64 instances that I can create manually on a device, and each instances can have any number of VLANs. There is no limit for that. If you want to configure all 4094 in one instance, you can do that. If you want to configure 100 in one instance, you can do that as well. So there is no limitation of mapping the VLANs. In terms of instances, you can have totally 65. Of 65, 64 are user configurable, that is manually done, and this is automatically getting created as soon as you enable MSTP on a device. Okay, regarding point number 4, MSTP is open standard. That means this can run between a Cisco and a Juniper box as well. It's not a Cisco proprietary, it's a open box, open standard. Okay, what about point number 5? Now this is little bit important as well as it's little bit confusing. This is a concept of additional things in MSTP. So what it says is, it talks about two new key terms. One is IST master and one is CIST root. Now IST is nothing but internal spanning tree master. Internal spanning tree master. And this is called as common and internal spanning tree. Okay, so that is what I have mentioned here, common and. So now what are these two terms? So let's say I have 4 Cisco device. I'll just make it simplest so that you can understand. So let's say I have 4 Cisco switches. Let's configure one MSTP region here. So in MSTP we have a topic of region. Okay, so let's say I'm configuring region over here, region 1. Similar way, let's say this is falling under region 2, MSTP region 2, and over here I am making use of either your legacy STP or your RSTP. Okay, because that is also possible, right? Might be out of 1,000 devices in your enterprise, you're migrating few blocks, like you're migrating first 100 to MSTP and then next 100. So basically they are interoperable. Okay, they are backward compatible. So let's say this is the scenario where I have MSTP region 1, MSTP region 2, and then I have one Cisco device falling under STP and RSTP. Now what happens is the election will happen in according to the region. So between these two boxes, one has to be root bridge. Now that root bridge is called as IST master. It's called as internal spanning tree master. The normal calculation, then how is the elections done? Elections are done based on the bridge ID equals to priority plus MAC address. The same concept. Okay, concept remains same. Only thing is the terms are getting introduced. The new terms are getting introduced. Let's say among these two switches, this is having the lowest bridge ID. So this becomes a root bridge, right? In a legacy or in RSTP, we call it as root bridge. But in MSTP, we call it as IST master. Okay, every region will have a root bridge called as IST master. Just a new term used. Normally it's a root bridge only. It's nothing new thing here. It's root bridge but called as IST master, internal spanning tree master. Now what is CIST root? So let's say now I have two region, right? I have MSTP region 1, I have MSTP region 2. Now who is going to be the root bridge? Is it going to be this person or this or this? Now I'm talking in terms of region. Okay, in my previous scenario I told about within a region among two devices, two Cisco switches, one became root bridge which was called as IST. Now I'm talking about two region number 1 and region number 2, and again the same concept. Okay, depending upon the bridge ID, because we never know, might be this is a better superior BPD, might be this have a bridge ID. Now this will become CIST. CIST is nothing but common and internal spanning tree. But let's say this is once again a better BPD. Now this becomes CIST equals to IGT. Now these are few terms which you will understand by rewinding this video once again after the class, or you have the notes with you. Okay, so these are the terms which you need to know in MSTP. So IGT or IST, sorry, it's IST, internal spanning tree protocol or internal spanning tree master. It's between the same region. Okay, so basically in region number 1 among two devices, who is going to be root bridge? So that root bridge switch is called as IST. Now when I have two different region, now who is going to be the root bridge? It can be this as well, we never know. Might be if it is having a better bridge ID, then yes, it will win the election of CIST. But let's say if the let's say if this is still better than this, now what happens is we call it as CIST equals to IST. That is, your common internal spanning tree switch is same as your internal spanning tree switch. Okay, there is one more possibility here. The possibility is, let's say if this becomes CIST. Okay, so that is also possible because this can have a better BPDU than this. So now what happened, your CIST is a different switch, your IST is a different switch. Okay, so these are two different scenarios where we can talk about, or we can correlate these terms, IST and CIST. Regarding the sixth point of MSTP features, so what we learned in RSTP was RSTP will support uplink fast, backbone fast. Okay, one second, just a minute. Okay, fine. I guess there was some latency. Okay, fine. So these two add-on feature we checked out in RSTP. Okay, your STP don't have these two special ports. Your STP only has designated port and root port and the blocking port. Whereas in RSTP, we saw that we have designated port, root port. Along with this, we have something called alternative port and a backup port. Right? These two were added on feature in RSTP to give you a better convergence timer. In case of MSTP, we don't have this support. Okay, this is not supported in MSTP. This is only part of RSTP. But yes, we have port fast feature for MSTP, and also we have the other add-on features like BPDU filter, BPDU guard in MSTP. Okay, fine. So these are few features, the basic features of MSTP. Now regarding to this diagram, let me explain what are IST, internal spanning tree, and what is CIST, common internal spanning tree. Okay, so let's say this is one region. Within this region, I have multiple Cisco devices. Let's take an example of 4 devices. Similar way, I have 4 devices here. Okay, so the election will happen on every region. So let's see, as you can see here, this is region 1, region 2, and region 3. So this topic also is in part of MSTP region. So you just group 4 to 5 Cisco devices in one region. So let's say in this region number 1, I have 4 switches, I have another set of 4 switches in another region, and so on. Now every region will have their election and they have to find the root bridge. Now let's say one of them becomes a root bridge. Now that is called as internal spanning tree. Now over here also election will happen and they have to find root bridge, and that is nothing but IST, okay, internal spanning tree. And similar way there will be also root bridge election happening here, and that router whichever wins the election will be called as IST, that is internal spanning tree. Now how do election happen, or how do root bridge get selected? Just the normal formula, that is bridge ID equals to priority plus MAC address. So based on this, election will happen, a root bridge will be elected, and that root bridge in case of MST is called as IST, internal spanning tree protocol. Now a whole election will happen on across all the 3 region. Okay, one switch will become a root bridge for complete 3 region. Now that switch can be part of this, it can be part of this, it can be part of this, we never know, right? The one with the better BPDU, one with the better bridge ID will become the CIST. Now let's say that is taken up by this switch, or let's say this switch. Okay, now we call this switch as CIST, that is common internal spanning tree. So this switch is an root bridge for your complete MSTP topology in the network. And also, as per region, you will have separate election, and we define that as a IST. Okay, so that's first regards to this diagram. Okay, now coming to the instances, what happens when you enable MSTP on a Cisco box? By default, on your Cisco box, it will be on STP. Some higher end are on PVST, and some devices like XE based devices, they will be running on RSTP. Okay, so these are few spanning tree which will be by default enabled on the Cisco boxes, but it's very rare, or I can say there are no switches which will predefined or inbuilt running on MSTP. This has to be manually configured. Okay, so let's say we are running either one of them. Let's say we are running on a STP itself. So I will go to configuration mode and I'll make a command spanning tree mode MSTP, which will enable MSTP mode. Now, as soon as I enable this, there is a concept of instance here, instance number 0, which will get automatically triggered. Okay, and that's what we are going to discuss now. What is that going to do, or how is it going to help us? Okay, the instance number 3, instance number 0. So instance number 0 is also called as internal spanning tree. Okay, it's called as internal spanning tree. Now don't get confused with the previous keyword that was master. We called it as internal spanning tree master. Okay, now this instance we are calling it as internal spanning tree. Okay, so this is called as internal spanning tree. What is the second point says? This instance will be existing even if no other MSTP instance are created. So in a switch, I just enabled MSTP, so my instance 0 will automatically get created. Now I don't have to make any new instances. Okay, even though I have not created any instances, this will be running. Now I can map all my VLANs straight forward to this instance itself, but the best practice is, let's not map VLANs to instance 0. Instead, we create a new instances, and then we will map the VLANs like 10, 20, 30 to instance number 1, and might be 30, 40, 50 to instance number 2. So this will be just be there. But there is, yes, there is one more reason why we need this. Okay, I'll tell you. So without any additional configuration, all VLANs will be mapped to this instance. So let's say I have not done this configuration. I am not doing the mapping work. So all my VLAN from 1 to 9, 1 to 4094 will be by default mapped to instance number 0. Okay. So this I'll show you during the lab as well. All the set of VLAN, extended VLAN will be by default mapped to instance 0. The instance is only instance that will work with STP switch running out of MSTP region interoperability. Okay, so that means in case I have multiple switches, let's say this is running on MSTP. Okay, and let's say this is running on STP. Now how are they going to be synced, right? So what happens is, in this particular switch, it's your instance number 0 that's providing the backward compatibility with the legacy STP or your RSTP. Okay, it's your instance number 0. That is why this is used for your backward compatibility also. Okay, so that's the reason, or that's the things about instance number 0. Now regarding the cost value, so cost value is on a higher note. Okay, so if you talk about your STP and RSTP, you had a different cost values depending upon the Ethernet medium. Similar way on your MSTP also this will differ. So let's say I have 4 devices. So let's say this becomes the root bridge. And now from switch 4 point of view, I have to see how do I reach the root bridge. Okay. Now the cost matters a lot, because that is how we are going to see which is going to be forwarding and which is going to be blocking, right? So let's say every interface will be given a cost value based on these tables. Okay. 4, 4, 4 and 4. So basically this is for 1 gigabits per second, that is this one. Okay, in your legacy STP you have the cost value of 4, but in case of MSTP, instead of 4 you will be seeing 20,000. That is from this table, you will see it in 20,000 range. Okay, so that's about the cost value. So you have to follow this table in case of calculating MSTP or in case of tuning. Okay, now regarding the terminology of your MSTP. So we discussed about IST master. Every region, let's say this is a MSTP region 1, MSTP region 2, MSTP region 3. Let's say there are 4 to 5 switches on every region, something like this. So the election will happen on every instances. There will be one root bridge on every instances, and that is called as IST master. IST is nothing but internal spanning tree master. Who is CIST root? It's the one who becomes the root bridge overall in a overall topology. Okay, it can be the switch belonging to this or to this or to this. So the one who becomes a root bridge to a complete MSTP region or MSTP topology is your CIST. Now there are two possibilities for your CIST. The possibility is, let's say from your region 1, from your region 1 point of view. Now CIST can be IST also. Okay, your CIST can be IST also, only when, let's say, this switch has a superior BPD when compared to everyone. So this goes to, so this becomes CIST. And also when compared with this 4 switches of region 1, this was IST. Now IST equals to CIST. Now let's say this is not the case. So in this region, IST is this. Let's say this is a better switch with better BPD, but overall in the topology, this is better. Okay, so this becomes the CIST role. Now, the connection between these two is called as a master port. Okay, this is a again a new term introduced in MSTP. What is a master port? It's connectivity from region to CIST route. So connection from region, any region, it can be this, it can be this, to CIST. CIST is nothing but the one switch which is having a better or a superior BPD throughout the topology. Now the connection among them from this region to this becomes a master port. So I can show you that in a lab also. So something like this, when you see a new role called as master, it's because that's between region to another region where your CIST is falling. Now this switch will have a port role called as master. Okay, so this is a condition in your case, because every spanning tree had something on its own, right? Your RSTP had two extra port introduced, alternate port, which is called as uplink port, and also you had something called backbone port, which is backbone fast port, right? Similar way here you have terms like IST, CIST and master port. Okay, fine. So this way regards to terminology, and yes, you have the support of alternative and backup still on MSTP. Your MSTP will have the ports like alternative and backup what you had in RSTP, Along with that, you will see one more extra port which is in defined in this way, master port. Okay, regarding the configuration, I'll directly do on a GNS lab, so things will be much more easier. Okay, regarding MSTP tuning, same as your RSTP and STP. So I'm not going to confuse once again with this. Okay, so I'm going to keep this very simple, because the more I talk about MSTP, you will start forgetting what you learned in previous class. Okay, just let me tell you the tuning that we did in the case of STP, the case in the tuning that we did in STP and RSTP was based on priority numbers, or by setting up the keyword like primary and secondary, if you remember, right? So let's say if I have 4 devices, this by default take the role of root bridge. Now what I can do is I can go quickly to this switch and I can set the priority to 0 or 4096, or I can make use of the word primary or secondary. Now what happens is this root bridge will be assigned to this, because we have a superior uh, BPD with a better priority. Okay. Similar way, on a secondary box, we can set the configuration to keyword secondary, or let's say I have 0 set here, I can set 4096 here. Let's say if I have 4096 here, I can set 8192. By default, all are running on 32768. Agree? So based on this, we were manipulating the switches. The same concept even in MSTP. Okay, let's say we have 4 devices, one of the access which takes the root bridge or IST master role. Now I don't want that access switch to be this, so I can change uh, this value, and that's going to tune my device. Okay, so as same as your the normal STP. So I'll let you do this lab on your own. I have it on workbook, just follow that and do it, but I'm not going to cover in the class, because the more I go ahead, you will start feeling it complicated, right? So as I'm telling, this is very similar to your STP and RSTP. The second thing that we did was, let's say I successfully made this root bridge. Okay, now what happened was I have 2 links between these 2 switches, switch number 3 and switch number 1. Now by default, your lowest ID is going to be forwarding, and your second link is going to be blocking. So what did I say in case of STP and RSTP? Yes, we can do the changes. How? Either I can manipulate the cost. If this blocking, let's say the forwarding had a cost of 4 in case of STP, I just reduced to 2, and now this became forwarding. But in case of MSTP, we will not see it in terms of 2 and 4. It will be in terms of 20,000. So what you need to do is you need to lower the cost of this link. So if you make it say 2, so let's see what is the lowest value than 20,000 in terms of MSTP. So in MSTP, after or below 20,000, you have 2,000. So you can make 2,000. Okay. So what you do is just make it 2,000. So as soon as you make 2,000, the cost value of this will start forwarding, and this will be put in a blocking state. So that was manipulating of a link on in terms of cost. Now similar way, we can also play around with the priority of a interface. So let's say the priority of this is 128.3 and this is 128.2. Now this is lowest, that is why this was by default forwarding, and this was put up on blocking, right? So I can just change the priority, and the command is once again the same. You just go to the interface level and call the command spanning tree port priority and change the value to like 32 dot just put it at 32. That will make this to be 32.3. Now this second link will become active. Okay, so these are the MSTP tuning, which is very similar to what we learned so far. So I'm giving this as an assignment or as a homework, which you guys can uh, practice on your own on the weekends. Okay, now regarding some common MSTP issues or some common issues that we find out due to MSTP misconfiguration. So one of them is if the mapping is not consistent. That means, let's say I have switches. You are creating two instances. Okay, you are creating instances number 1 and instance number 2, and by default, yes, your instance 0 is coming. So let's not talk about 0. Okay, let's talk about 1 and 2. Similar way, I create 1 and 2. Now let's say on instance number 1, I am going to map 10, 20, 30, 40 here, but on this side I am not consistent. Might be I mapped by mistakenly something else like 2, 3, 4, 5. Now then this instance will not be eligible for any root bridge election. Okay, so that is why just make note of your VLAN assignment to these instances. The second thing is pruning. That is, let's say I have three switches in this order: 1, 2, and 3. Okay, so let's say we have VLAN 10 here and we have VLAN 20. Now someone enable the pruning. I told you, when you enable pruning, your unwanted VLANs will be put up on a idle. So what exactly does pruning do is, it will reduce the unwanted broadcast in a trunking. Okay, it will reduce unwanted broadcast in trunking interface. Let's say these are all trunking interface, and every interface had some multiple VLANs allowed. Okay, let's say we have 10, 20 all around. Now a user who is trying to ping the other user on the switch number 2. So let's say this is PC number 2 and this is PC number 1. So let's say he's trying to ping something. Now what happens is, his packet will be sent to both the interface, and since this is a part of trunking, now there are multiple VLANs here. So this will get hit on every VLANs in case of non-pruning scenarios. In case of non-pruning scenarios, whatever packet hits the trunk will be part of multiple VLANs, and all the VLANs will be uh, triggered up. So what we do is, we just enable VTP pruning. So in case of VTP pruning, what happens is, if the traffic was only for 10, now rest of them will be put up in a ideal mode. Okay, so now the hit will be only on this particular VLAN, not on the others. So it's to reduce the unwanted broadcast. Okay, and then it will carry forward, the same thing happens, and then that's what we do it. Now the issue in MSTP is, let's say we have pruning enabled in this scenario. Let's say pruning got enabled and your VLAN 20 was put up on ideal here, and similar way your VLAN 10 was ideal on this. Now when someone is pinging from, let's say from someone pinging on a user who is falling under 10. Okay, okay, let's take it as 20. So in this case, what happens is, your VLAN 20 is in ideal state, so there is no way your data will flow over here, because you started pruning. Your what pruning has done is, pruning has put 20 and 20 on a ideal state. Okay, now you cannot send your data packets to this side, even though you change the you change the VLAN configuration, but your MSTP will remain the same. Okay, your MSTP is based on instances. It's not based on per VLAN basis. If it was RSTP or STP, as soon as there was the issues or there were configuration with respect to VLAN, your STP would have recalculated, right? It was on per VLAN basis. It would have recalculated and it would have said let's allow this or let's block this. But in case of MSTP, you made use of instances. MSTP will not revoke its topology change in case of VTP pruning. So that is why it's said that these two are some normal behavior when we can see MSTP getting flapped or MSTP showing us abnormalities. Okay, fine. So let's configure MSTP and I'll show you the different terms here and the tables of MSTP. So for that I have taken up four devices, four switches, and from my previous lab we have VLAN 99, VLAN 100, VLAN 10 and VLAN 20 placed on all the four of them. Okay, so that is why I did VLAN and VTP lab in the previous class, because I need multiple VLAN in the case of MSTP. So now what I did is I have all VLANs across these switches. So every switches will have this. So let me show you that. So let's take the console of this. So if I have to show you the VLAN configuration, so it's show VLAN brief, where I have four VLANs already created. And on what STP am I running? So I'm running at this moment on my default STP. So what is the default STP behavior? It's a per VLAN instances. So I should be able to see separate instance for this, a separate STP instance for 99, similar way a separate instance for 100 and 110 and 120, and also for 666. So let's check it out that. So I can see a separate instance has been created for 99. I have a separate instance for 100. I have it for 110 and I have it for 120. Now the issue with this kind of legacy method is during any changes or during any topology changes, the BPDU from every instances will be advertised. Okay, so we don't want to do that. What we do is we make use of MSTP, where I will group two instances. I'll make two instances and I'll map this four VLANs. So I can say I'm grouping first two VLANs to first instance and the second half or the last two on a second instance. Okay, so that's going to help us avoiding multiple BPDU flows. So as of now, the normal behavior of root bridge election. Okay, so this is not a root bridge at this moment. So let's see which is the switch which is acting as a root bridge. Okay, so this is my switch 3, which has become the root bridge in case of a legacy STP method. Okay, because of a superior bridge ID. Now let's configure MSTP on this and let's see what's going to happen. And also let me tell you what is my uh, lab requirement. So let me open up the workbook. Okay, MSTP. Okay. So as per my lab requirement, I say that configure MSTP and verify the behavior. Configure MSTP and RSTP, verify the behavior and all other things. Okay. So all other things I'm going to give you as an homework or a assignment, which you can try it out during weekends. Okay. Because they are same as your RSTP and MSTP. So the one which we are doing right now is to see the behavior of MSTP, MSTP versus RSTP, and MSTP regions. Let's say region number 1 with MSTP region number 2, and we are going to see the concept of CIST, IST. Fine. So in this particular diagram, these two switches will be part of my MST region 1. Okay, and I'm going to create two instances, instance number 1 and instance number 2. So instance number 1 will be mapped with 99 and 110. Instance number 2 will be mapped with 120 and what else I have, 110 versus 120. So this is 99 and 100. Okay, so we have 99 and 110 mapped to first instance, second instance mapped with 110 and 120. Okay, so for a switch 1, this is going to be primary, whereas this is secondary. Now the same thing has to be recreated here, but the roles will get changed. So let's say instance 1 mapped with 99 and 100, instance number 2 110 and 120. Now in this case, this is going to be secondary because primary is your switch 1, and then this is going to be your primary. So now what happens is the root bridge election happens based on instances. So instance number 1, your switch 1 becomes a root bridge. In case of instance number 2, your switch number 2 becomes the root bridge. Now the ports gets load balanced. So whatever instance, for instance 1, if one of the port was blocking, now that port is enabled for your instance number 2. So that's how we are going to achieve the load balancing in MSTP. Okay, and to show you the topic or a concept of CIST, I'll make use of one more region here, which is called as MST region uh, 2. Let's say region 2. And here my intention is not to do the root bridge, all those things. My only intention is to show you the CIST and show you that master port concept. Okay, I told you something called master port, right? So I'll show you those two things over in this, and this particular thing, let's keep it for our STP or RSTP. So we can see that how the backward compatibility is going to work in this scenario. Okay, fine. So I guess scenarios are understandable, basic scenarios, nothing much here. So let's start with the first device. On the first device, I'm enabling MSTP, okay, with this command. To make any changes, I have to write, or I have to go to the MSTP configuration mode, and then I have to define the region number, revision number, and the instances. So there are two instances, and as I told you, first instance mapped to this and second instance mapped to this. And yes, regards to the priority. Now how are you going to say that this is to be uh, primary on switch 1? That is because of this command. Okay, and how is this going to be secondary on this switch? Because of this. Similar way, when you talk about the second switch, your commands will remain same till here. It's only the switching of primary and secondary. So the primary over here becomes secondary here for that instance 1, and the secondary, which is instance number 2 acting as secondary, becomes primary on the second switch. So let's configure one by one. So then we'll talk about the rest of things. Okay, so on this switch, let's go to configuration mode. Let's enable spanning tree MSTP first. So I'll just make use of spanning tree mode MST. Okay, now I am on MSTP mode. So how do I check? Just with this command. So it says that I am running on MST, And what do you see? My instance 0 automatically started, right? As of now, I don't have any other instances, but instance number 0 got triggered up automatically. This was which discussed in theoretical few minutes back, right? So we can see the instance 0 coming up. Now let's configure the MSTP configuration. Okay, so to do that, I have to go to the configuration mode of MST. So let's say spanning tree MST configuration, and then I'll name the region. It can be any keyword. Okay, it don't have to be region. It's just a word. So for my simplicity, I'm making use of the word region. Let's give a revision number. This is very important. Okay, the revision number should match. So what are the things that should match is, in order to your MST to work, it's your revision number, it's your mapping. Okay, so these things should be set accordingly, or it should be consistent. Okay, if you don't follow this, then your MST will not work. So that is why I said revision number as 0 as of now. Sorry, revision number of 1. So if you see what is the range, it's anything from 0 to this number. I'm just taking up with 1. Okay, now let's create instance. Two instance I'm going to create. Instance number 1, and I'm going to map the VLAN. So how many VLANs do I have on all my switches from my previous lab? It's 99, 100, 110 and 120. So first two will be mapped to instance 1, and the last two will be mapped to instance number 2. So let's say instance number 1, and what am I mapping? 99 and 100. Similar way, I am going to map instance number 2 with VLAN 110 with 120. Now time to set the priority, but let's say I don't set it now. Okay, let's keep it pending as of now. So I'll go to second switch, and let's do the configuration which I did as of now. So I'll go to switch number 2. I'll enable spanning tree mode MST. Let's go to spanning tree MST configuration. Let's call this as region 1. Let's give the revision number 1. Let's say this is instance 1, and the VLAN mapped are 99 and 100, and the second instance will be mapping to 110 and 120. Okay, so if you see, as of now, it will be your normal root bridge election. Okay, so whoever is having the better bridge ID will take the election, or it will win the election. So let's see by making use of show spanning command. So when I do this command, I have MST 0 by default, so I don't have to worry. Let's see what else this does get created. Now I have MST 1. This is nothing but instance number 1. So under instance number 1, I can see some keywords, okay, master, all those things. But I'll show you this in the later on also. Let's focus on instances first. And along with that, I also have instance number 2, where I have 110 and 120 VLANs mapped. So how do I check that? Which instance is mapped with which? So the command would be show spanning tree MST1. So if I do this, I can see the details. So basically this is acting as a root for MST1, that is instance number 1. And I have two VLANs that is mapped here. Similar way, if I do check the instance number 2, I have 110 and 120 mapped here, and this is acting as the root. So let's see the second switch. Let's check it out from the second switch point of view. Show spanning tree MST1 and show spanning tree MST2. Okay, so these are the details that we just got it. Okay, and if we see only the spanning tree, so it says this is a bridge switch for MST1. That is not of my interest, because for MST1 it will be all the VLANs, all the other VLANs of your extended VLANs will be mapped to this. So how do I check that? With this command. So if you see, all your VLANs, your VLAN 1 till your 4094 is by default mapped with instance 0, which is automatically getting triggered up. So out of that, some few are mapped to my instance, the instance which I manually created. Okay. So let's see from MST1 and MST2. Okay. So this is how we check the instance. Now let's say I'm trying to make the priorities. Let's say the priority has to be changed. So I'll go to the first switch. I'll say spanning tree MST instance number 1 will be primary on this box. Okay, so instance number 1 is primary, and the same command I'm going to copy the same command and put up on the second device, but I'll change the priority number. Okay, I'll make it 4096 because I want this to be secondary for instance 1 and I want this to be primary for instance 1. Okay, so let's put it up. Now similar way, what I'll do is I'll make this as secondary for instance number 2 with this command. So in case you are getting little confused, so let's first do this on the second device. Okay, so on the second device I say instance number 2 is primary. Okay, instance number 1 was secondary and instance number 1 is primary, and on the switch number 1, squad switch 1, instance number 2 is my secondary. Okay, vice versa. This is for the load balancing purpose. Okay, now let's see the spanning tree status. I am not focusing on instance 1, so let's see from point of this. So as I configured MST1 to be the root, it has become root. But let's see on my second device. So I can straight away go and hit instance number 2, but let's first check with this and then we will go there. Okay, so if you see now, MST1 is no longer a bridge here because we manually configured MST1 to be bridge on the switch number 1, that is Scott switch 1, where your instance 1 is your root bridge. Okay, your second switch is not a root bridge. Now regards to the second instance, if you talk about MST2 instance, now this is not the root. How about this switch? Let's check it out. So if you see here, now this is acting as a bridge for instance number 2. So what does it prove? So it proves that when I have two switches, when I have two instances running, okay, so my first instance become root bridge in case of switch 1, and in case of switch 2 my instance number 2 becomes the root bridge. Okay, in case a link goes down, then we have the secondary configured, so you don't have to worry about the switch going down in case of MST because you have the secondary configured. Okay, and similar way it is also giving us the forwarding nature of the interface. The reason is, for a root bridge it will be designated always from the point of root bridge. When we have root bridge on this, then this will be forwarding. So in totally both are forwarding from point of instances. Okay, so that is a plus point of MST, where we see both of them acting as forwarding basis on instances based on VLAN. So let's say for the first VLAN, for this set, these two VLANs might be the first link was blocking, but when we see from the second switch point of view, that this VLAN will be forwarding for on those blocked links. Okay, fine. So that's regards to the MST and MST instances. So from the details, I can show you that the cost have been increased. They are in 20,000. That's all because of your MST cost table. Okay, so for 1 gigabits per second, the cost is 20,000. So this is the cost. We are running on 1 gigabits per second interface, so we can see the cost to be in 20,000. And yes, we discussed P2P. It's when your two links are in full duplex. Okay, the moment you make one to be half duplex, this will get to the shade type. And what is this? This is when you have your interface 0/2 and 0/3 with another switch which is running on a different STP version. So let's say RSTP and MSTP. In this case, these two interface will be type bound PVST. So that means we are running MST on one switch, whereas the interface are shared with another flavor of spanning tree. Okay, fine. So that was regards to region 1. Okay, that was regards to region 1. We saw that root bridge election happened based on instances. We are all good with that. So what I'll do is I'll also create one more instance. So for creating that instance, I'll prefer switch number 4. So let's go to switch number 4. That's this one. So as of now, it will be running on a legacy box or a legacy spanning tree, that is PVST. So let's see the MAC address once. Okay, it's 9156. Okay, fine. We are good with that. Okay, so let's configure the region or a different set of regions. So let's go to config T. Let's go to spanning tree mode MST, spanning tree MST configuration. Let's call it as region 2. Let's give a revision of 1. Let's create instance 1 VLAN 9900 and instance number 2 VLAN 110120. Let's also set the priority, but setting a priority is just to test few things. Okay, so let's say I'm going to set some higher value 18192 and MST2 also on a greater node. Okay, so when we have one region, I showed you the root bridge, and root bridge is also called as IST master, internal spanning tree master. Now when is CIST coming into picture? When we have two different regions. Okay, when I have one region and two MST switches, the root bridge switch is called IST master. Now let's say I have one more some other region, and I have the connectivity like this. Now I have to select CIST. CIST is something when I consider the total topology. So among this total topology, which switch is going to get CIST? So again, it's based on the lowest bridge ID. Okay. So let's see who gets that role, and to verify that, I'm going with show spanning tree MST command. So this is not a CIST device. Okay, let's see on switch number 1, show spanning tree MST. This is neither CIST. Let's see the switch number 2, show spanning MST. Now if you see, this becomes CIST. Okay, this has won the election because of its lower MAC address table. The priority is same everywhere. That is what we discussed. The MAC address of your switch number 2 is better than other two. Okay, so what happens is this switch gets an this switch is called as CIST, common internal spanning tree. Now the link from this region to get connected to this will have a new port role which is called as master. So let's verify that on switch number 4. So when I go to switch number 4, okay, and let's see the MSTP configurations. So do you see the role of master? These are this is a new port role which is in MST. Okay, let me tell you with the help of diagram what I'm talking about. Okay, so this two switches, the first two switches are part of MST region 1. This is a part of MST region 2. So within the same region, there is a normal root bridge election, and then we call it as IST master. Later on, we had to find out CIST. CIST is when you totally compare all the four devices. Even your common spanning tree switch will also be included. Okay, so in this scenario, in case of our lab setup, this this had a very good superior BPD. So this took the role of CIST. Okay, now what happens is any other switch belonging to any other region will make a path calculation to reach this CIST. Now these two links, which is 0/2 and 0/3, will be getting an new port role as master. Okay, master port, it's called as master port. So if you see this, 0/2 got the master and 02 got the master. Why do I see 02 got the master? Because 03 is put up on a blocking, 02 is still forwarding for your instance 1 and instance 2. So this is your instance 1 and this is your instance 2. So both the instances are now forwarding on your 0/2, whereas your 0/3 is down. And this is what I told you when while you doing the assessment in during weekend, you just play around with the port security, not port security, port priority and port cost, and try to make this as blocking. Automatically this will take the role of master. Okay, now what is master? Let's quickly go back to the theoretical document. So let's see what is master. So master is nothing but provides connectivity from region to CIST route that lies outside the region. Okay, that means when you talk from this region point of view, now where is your CIST residing? It's residing outside of this region number 2, and now this is a connectivity from this region to that CIST switch, and this gets a role of master port. Okay, this is a new port role in case of MST, like how we had alternate and backup in case of RSTP. So what did we prove? We proved master, we proved what is CIST, we proved IST. Okay, now there are two possibilities in case of these two. Okay, the first possibility is CIST equals to IST master. So this is in the case when your CIST is a part of region 1. So let's say in this case, region number 1, this becomes my IST. Okay, and also this becomes CIST. Now that is that's a scenario when I call it as CIST equals to IST. Now this don't have to be always the same, because sometimes even your non MST switch like RSTP or the normal STP can win the election, right? And it can take the role of CIST, or else another region can take the role of CIST, right? So that is when your CIST is different and your IST would be different. Okay, the two possibilities. Fine. So regards to the region number 2. So we just saw from this region point of view. So the instances had a root bridge depending upon priorities. Now when I have only one switch falling under this complete region 2, what would be the root bridge? Whether the root bridge will be pointing to the other switches, or it will be pointing to the non-MST switches, or whether they are going to do the recalculation, or whatever calculation they are going to do will reside within this region. Okay, so that's something which we have not checked. So I'll go straight to the switch 4, and if you see the command show spanning tree MST, let's ignore instance 0. That's not what we are looking for because we have not configured. So if you see from point of instance 1, instance 1 is a root. Okay, it's a root, and also your MST2 is also root. So what happens is, what does it prove is, every region will have its election. So election in the case of region 1 was between two switches and between two instances. In case of in case of region 2, there are no other switches to do the election. So what it declared himself as a root bridge for MST1 and MST2, instance 1 and instance 2. So that is what it says. The switch 4, which is a part of this region where you do not have any other switches, it's going to make itself as a root bridge. The moment you bring one more MST device, the calculation will happen between these two, and then they will share around, okay, depending upon the configuration that we do. Let's see from the point of non-MST device ones, okay, that is this device. So let's see what is happening on that box. So if I do show spanning tree, it's running on the legacy box. The root ID has been taken up. Okay. Now, which is this root ID? Now you know that there are two set of information. One is root ID and one is bridge ID. Bridge ID is local to this box, local to this switch number 3. But as we know, root ID is always be pointing to the root bridge of that network. As of now, who is your root bridge? It's your CISC router. CISC switch. Okay. So this is CISP switch, which has a better or superior BPDO in this among these 4 switches. So let's quickly verify if this is pointing. Okay, so okay, this is VLAN 1. I am not going to bother VLAN 1 because I have not enabled VLAN 1 on these two devices, or neither on this. So there is no point I check VLAN 1. I need to check the root ID for 99, 100, 110 and 120. And I'll also share one silly thing after this. Okay, so give me some time. So I'm going to ignore VLAN 1 because that is not something which I'm looking for. So let's see for VLAN 99. So as you know, for a legacy STP, it's a per VLAN. So every VLAN will have its own configuration. So it has route ID as well as bridge ID. Bridge ID is nothing but of your switch number 3, that is your local switch. Root ID is your root bridge of this topology. So we know that this is CISP. So let's verify if this is your switch 2 or no. Okay. So let's quickly go to switch number 2. And from switch number 2, let's verify the MAC address of your instance number 1 or instance number 2. Okay. So let's see instance number 1. So when I do this, I have okay, one second. So which is my CISP? It's instance number 0. So I have to check for instance number 0. Okay. Because it's your instance 0 which is giving you the backward compatibility between your MST and your STP. Okay. So from STP point of view, it's going to recognize your instance 0. It's not going to recognize 1 and 2. 1 and 2 are custom instances for your load balancing. But when you guys have two different flavors of STP, then it's your MST0 that comes into picture. And what is the address of this? It's 951B100, and this is a CIST, Common Internal Spanning Tree. So let's verify by going on to switch 3. And if you see this, is it same? Yeah, it's same, right? So what does it prove? Once again, it proves that when you take all the four switches into consideration, this has taken the role of route bridge, though they are running on different flavors of STP. That is, this is MST region 1, this is MST region 2, and this is running on your legacy STP like STP or RSTP. You can try with RSTP also. The thing that it proves is it's going to, okay, I guess I'm audible. Okay, so there was some slight latency. Okay, so what happens is all of them are pointing to this switch now. So this becomes your root bridge, and in terms of MST, we call this as CIST, IST master. We discussed about the master roles. Okay, so yeah, so this ends your MST. So let me quickly see if I have missed out something. Yeah, once again, tuning is something which I want you to take it as a assessment. Okay, so it would be practice for you guys to set up this lab MST, check various thing, and then you can do the tuning. For tuning at this moment is very easy. When I have configured all the four devices, I can quickly quickly tune this. But I want this to be done by you guys, okay, during the weekends. Don't have to do it today. You can take your weekend. You can spend some time, okay. So what you have to do is you can play around with the root bridge designation first, okay. So let's say as of now this has taken root bridge, or this has become CISP. Now how if I make this as a root bridge or this as a CSP? So just go around and change the cost value, or you can change the priority value, and then you can change the behavior. Similar way, in let's say you have two links, it's 0 1 and 0 2. So by default your 0 1 is going to be forwarding, and this is going to be blocking. For some reason the SFP modules are abnormal, they are not working as expected. So you want to tune this, so you can change the cost value of this interface, or else you can change the priority of this interface so that your second links comes up, okay. So this is something which we already done in the previous case. Let me see if I have to cover something, okay. And at the end of this I have given you all the configuration. So these are generic configuration, not from the lab point of view. And there are some quiz here. Which of the following issue does MST resolve? Which MST VLANs are directly associated with? Okay, something which we were talking or discussing about, and the answers are once again at the end. So I would prefer do some honest quiz so that you know what you understood and where you stand. Okay, so this is a theoretical document, and from lab workbook point of view I have the configuration MST. The tasks are being defined, the configurations are mentioned, the outputs are shown. Okay, you have all your master coming up. So basically, where do you see CISP? On your switch number 2. Okay, so on switch number 2 on the MST 0 or instance 0 is used for inter flavors of STP connection, or when it's about the total topology of your network, then that's what the root bridge gets elected, and that's become CIST. Okay. And one of the switch done on RSTP. So you can see the behavior of your legacy spanning tree. They are running on multiple instances. Every VLAN have their own instances, whereas MSTP it's just two instance 1 and 2, and 0 by default it's get created. And the master role port election, that's when between two different region you need the connectivity to the CIS or the CIS switch. Okay. And yes, in case you're stuck with the assessment, you have the configuration. So when you're playing around with the root switch manipulation, you can play around with this. When you have the port priority concerns, you can play around with this commands. So I've directly given you the commands as well. Okay, and also I have given you the verification command. Regarding the MST timer, yes, you can tune the MSTP timers. By default, what is timer, or what is it? It's nothing but your BPDU advertisement timers, right? So BPDU is always 2 seconds in every spanning tree flavors. But yes, we can change it with this command. Spanning tree MST hello timer can change that. Similar way, forward delaying. What is forward delaying? From your listening learning state, transiting to the forwarding state, that's called forwarding delay. So by default it is 15 seconds. In MST we can change that as per the network requirement. What is maximum age? It's a hold timer, or it's a dead timer. So your neighborship relation is valid till by default 20 seconds. If the BPDU gets failed for complete 20 seconds, then the reconvergence will happen. So you can, yes, you can change that timer as well. And yes, one more important thing is when we have multiple spanning tree running. So let's say I have MST running here, and I have some other type of spanning tree running on this side. Now you have migrated this to MST and you have RSTP. Now this will not negotiate. You have to trigger manually. And what is the command to trigger? That is this command. Clear spanning tree detected protocol. So basis on this command, they will start negotiating. Okay, this is something which you have to do when you do the migration from RSTPs to MSTP. Let's say they were all in RSTP. By default they were all in RSTP. Now you migrated the first two to MST, so they will not negotiate. Okay, they will not negotiate, or they will still be operating on RSTP. So you have to make sure that you trigger this command so that they start negotiating. This is something very similar in even in OSPF scenarios. When you do changes in a OSPF routing protocol, you have to trigger the command clear IP OSPF process with the asterisk symbol. That will rephrase the routing, or it will renegotiate the OSPF state. Similar way, in your uh, multiple spanning tree network designs, you have to make use of this command so that you can trigger up the negotiation. Okay, fine. So that's from my side. So if you guys have any doubt, please let me know. So is this topic which you guys already were familiar from your previous certification or something? because this is something which was present in your previous or older CCNP routing switching, as also in CCI also. So I guess you guys might be aware of this, or at least known to these things, right? So any doubt? Did you understand, or did you not understand?
On my side, I'm fine.
Okay. Okay. So guys, I think
Uh,
we
for,
okay.
for me, unfortunately, I'll have to rewatch the video
Yeah, yeah,
because
yeah. I
I was in
yes.
I was in the meeting when yeah I was in the meeting when
Okay.
the class started. So
Yeah, I always suggest when the topics are new, always watch it for the next time or the second time before you join the next
yeah,
class, because we all some at some node we study this for the first time. So during live class or a live session, it will be not easier for us to catch it. Okay, we might miss some topic,
yeah,
and then the whole class becomes little complex. So if you go back and watch the recording, rewind to some extent, then this will make more sense. Okay, so yes, you can come back to the
absolutely.
next class and you can let me know if you have any issues with MST. Okay.
Okay,
Okay, so in case there's no more doubts, we are good to wind up. Okay, and we shall meet in the next class.
all right.
Okay.
So we'll be on tomorrow.
So what I was planning was, let's meet up on Monday, because we already had good number of sessions this week. So if you guys need some time to prepare or to rewind the videos, so let's cancel the class tomorrow and let's meet straight forward on Monday. Is that fine with everyone?
Yeah,
Okay.
yeah, I think
Yeah.
it's better because I mean,
Yeah.
well, I don't know. I mean, for me, I don't know about the rest
Okay. No.
because I
No,
mean,
I'm fine
I'm
as well.
working so and it's a lot to be honest.
Yeah. Yeah.
So I think 4 days is
Yeah,
fine.
I agree, because we had consecutive classes for last four classes,
Yeah,
so there might be a lot of
so I
things
think
which you would need to revise. So let's cancel
yeah,
tomorrow's class and let's meet up on Monday. Okay.
okay, yeah, I think 4 days a week is fine.
Okay.
Yeah,
Yeah.
that's
Yeah.
good.
Okay, guys. So let's meet up on Monday then. Have a nice weekend. See you all soon.
Okay, okay,
Take care.
okay. All right, guys, be safe out
You
there.
all.
Okay.
Thank you.
Bye.
Bye. Bye. Take care.